Greetings everyone. Please allow me to introduce myself. I am Imelda Mahendro Putri, a final year student at BINUS Online Learning University, currently pursuing a major in computer science. My student ID is 26022911166. In today's agenda, I will be creating a presentation video for Teach for Indonesia powered by Bina Nusantara. The theme that I will be discussing today is all about machine learning. The specific topic that we will talk about in this video is why does your machine learning model fail and how to prevent it. The reason why this topic is being chosen is these days we know that we are very close to the artificial intelligence world. And artificial intelligence is closely related to machine learning as well. Therefore, it's a great opportunity for us to learn machine learning even deeper than before. Before we go into our main discussion, I would like to explain several learning outcomes expected from this video. The first learning outcome is we will be expected to understand the introduction of machine learning. One of the agenda in this video is I will be explaining the introduction of machine learning in a very simple manner. It will be continued by we are being expected to understand how does machine learning actually work. The third learning outcome is we will be expected to detect machine learning failures based on its causes. And last but not least, we will be expected to be able to prevent machine learning failures. Without any further ado, let's start from the introduction of machine learning. So what is machine learning? Machine learning is a subset of artificial intelligence studies in which focuses on developing models and algorithms. Machine learning will allow computers to think and understand like human through data. Before I go explaining several types of machine learning, it's best for me to explain what is the actual difference between machine learning and machine learning model fail, as we will be encountering those words a lot in this video. So machine learning could be defined as the process, as the principle that we will be following. Meanwhile, the machine learning model is the product of machine learning. And this product means specifically following the process of machine learning. There are several types of machine learning. There are supervised learning, unsupervised learning, and reinforcement learning. The difference between those three are based on the data that they are used in their learning. The supervised learning uses the labeled data to predict. This unsupervised learning uses the unlabeled data to capture specific patterns. Meanwhile, the reinforcement learning will learn from trial and error from the data that they have. Moving on to the next discussion in here, we will talk about how does machine learning work. There are 8 steps that we will be discussing. We will start from the first one, which is problem statement. In this first step, we will be required to identify what is the problem that we're going to solve, what kind of solution that we will need in the future. And in this step as well, we're expected to ensure that the business purpose and the data learning that we are using will be aligned from one to another. After that, we'll be moving on to the next step, which is about data collection. Data collection is not only about gathering data. We will need to ensure the data quality, the data quantity, the data diversity, to ensure that the data relevancy is relevant to the solution and the problem that we are working on. After that, we will be moving to data cleaning. In data cleaning, we will be fixing missing variables, missing values. Therefore, the data itself can be used directly later on in feature engineering and exploratory data analysis. After we have ensured that the data is ready to be used, we will move on to the feature engineering. In feature engineering, we will be creating a specific feature to capture specific pattern. And in exploratory data analysis, we will be using statistical or visual tools to gain insights from the data that we will be using in decision making later on. After that, we can move on to the next step, which is data modeling. In here, we will select a model based on our complexity and scalability. Other than that, the model will also be trained by using iterative process, and we will validate it as well. And in model evaluation, we will decide whether the model is already a match for our business or not. In here, we will consider the accuracy, the precision, the recall, and the F1 score. And after we have a conclusion that the model is great for us, then we can move to optimization and deployment, which is the final step in machine learning. Moving on to the next discussion, which is the main topic of this presentation. Why it fails. Why the model could fail. There are three groups of causes of why the model could fail. We will start from data issues. There are three common causes, which are data leakage, imbalanced data, and sampling bias. In data leakage, it means the model accidentally receive what they are supposed to predict. For example, the model receive the test data set, like the key answer of the test data set. Because of this data leakage, it is most likely the accuracy of the model to be as high as 99% or even 100%, because they already receive what they are supposed to predict. And the second thing is imbalanced data. In imbalanced data, we are focusing more on one group only. For example, we have three groups of data, however, we are only focusing on one data only, which could change the overall relationship of all data and the prediction of it. Meanwhile, the sampling bias, it is because the data that we are using, it's not representative enough for the solution that we're trying to get or the problem that we're trying to solve. Moving on to the next causes, which is modeling and optimization traps. We have overfitting, underfitting, vanishing, or exploding gradients. For overfitting, the model tends to memorize it rather than predicting it. Meanwhile, the underfitting tends to predict it, but in a poor way. And the vanishing or exploding gradients is all about the weak or the strong signal on the prediction. Moving on to the next part, which is about the environment versus real world, we have concept drift and data drift. In concept drift, what changes is the concept of it, which means there's a there's a changes in the relationship between the input and output. For example, we're trying to predict the squirrel behavior, but we know from time to time the behavior could show differently, and that is what we call as concept drift. Because of the data change gradually, it will change the relationship between the input and output. Meanwhile, the data drift, the changes happens inside the data. For example, we have set the model to predict apple picture. However, we put the pear picture inside it, and that would be what we call as data drift. It is not relevant. The data that being put in the model is not relevant anymore with the data that we previously have trained. The last step is I will talk about how to prevent it. From the data stage, the prevention in data stage will include data testing and data splitting. The purpose of doing prevention in data stage is to ensure the data quality. It also helps with preventing data leakage to happen. So what we meant by data splitting is we will split the data into specific category. For example, data for validation, data for testing, data for training, and data for production. In that way, each data couldn't be mixed up from one to another, so it would prevent the data leakage situation. And data testing is when we are trying to calculate the accuracy rate, the precision, the F1 score, the recall. Therefore, we can prevent the failure of machine learning model. Moving on to the next part is how to prevent it in training stage. The prevention and training stage will include regularization and cross-validation. The purpose of doing prevention in training stage is to avoid its memorized character. So in regularization, it will help us to prevent overfitting. Because usually when the model is overfitting, it tends to be too complex, and regularization would penalize the model for being too complex. In another word, regularization will keep the model as simple as possible. And the cross-validation is quite different from the data splitting. In cross-validation, for example, we have 10,000 of data, and we will divide it equally into 5 data. So from 5 groups of data, we will be using the 4 data as our training data and 1 data as a testing one. Therefore, we can ensure which model is the best. The next part is how to prevent it in deployment stage. The prevention and deployment stage will include continuous monitoring and human in the loop. The purpose of doing prevention in deployment stage is to prevent any data drifting. For example, in continuous monitoring, it will be impossible for the model to have concept or data drift because there is someone actually monitor how the model works. And human in the loop keep the real-time feedback to fix the model as soon as possible if there is any inconvenience. We will keep someone expert on the data that will ensure that the data and the prediction will stay with our main purpose. So those are things that we have discussed in this agenda. We have several causes on why it fails, data issues, modeling optimization traps, environment versus real world, and there are several ways on how to prevent it in several stages, in data stage, training stage, deployment stage, by using data splitting, data testing, cross-validation, regularization, human in the loop, and continuous monitoring. So that's all from my side. Thank you very much for watching this video, and I hope this video could be your help in understanding more about machine learning. Before I wrap up this video, I will show you the references that I was using for creating this presentation. And thank you very much, everyone. I really appreciate your time.